Look at your hand. Now look at the screen you're reading this on, the air you just breathed in, a star sitting a billion miles away. Every single one of those things, and literally everything else in the universe, is built from just three tiny pieces. Three. That's the whole list. Learn these three, and you understand what everything is actually made of. So let's meet them. First, the stage they live on, the atom. Picture a tiny ball with a dense center called the nucleus and a blurry cloud buzzing around it. And here's the part nobody tells you. Atoms are almost entirely empty. If an atom were blown up to the size of a football stadium, the nucleus would be a single marble sitting on the center spot. Everything else is empty space. Inside and around that marble live our three characters. Meet the first one, the proton. It sits right in the nucleus, and it carries a positive charge. We call it +1. But the proton has one job that matters more than anything else. It decides what the atom actually is. One proton? That's hydrogen, the lightest thing in existence. 6 protons? Carbon, the stuff you're made of. 79 protons? Congratulations, that's gold. Change the number of protons, and you don't just change the atom, you change the element itself. That's why the entire periodic table is just ordered by how many protons each atom has. The proton is the atom's ID card, and that ID can't be faked. Now, sitting right next to it in the nucleus is the second character, the neutron. It's almost exactly the same weight as the proton, but here's the twist. It has no charge at all. Zero. Completely neutral. So what's the point of a particle that does nothing electrically? Stability. Neutrons act like glue and ballast, holding the nucleus together so it doesn't tear itself apart. And if you add or remove a few, the element stays the same. You just get a heavier or lighter version of it, called an isotope. Carbon with 6 neutrons is normal carbon. Carbon with 8 neutrons is the radioactive kind scientists use to date fossils. Same identity, different weight. And finally, the troublemaker, the electron. It carries a negative charge, -1, the exact opposite of the proton, but it does not live in the nucleus. Instead, it races around the outside, inside that blurry cloud, and it's tiny, almost weightless, nearly 2,000 times lighter than a proton. But don't let the size fool you, because the electron does all the interesting work. Electricity? That's just moving electrons. The little spark when you touch a doorknob? Electrons jumping. Every chemical reaction, every material, every reason two atoms stick together, that's atoms trading and sharing electrons. Everything that actually happens in chemistry happens out here in the cloud with the electron. So let's line all three up side by side. Proton, positive, heavy, lives in the nucleus, sets the identity. Neutron, neutral, heavy, lives in the nucleus, adds stability. Electron, negative, tiny, lives in the cloud, does the action. In a normal atom, the positives and negatives balance out perfectly, equal protons and electrons. So the atom as a whole is neutral, but knock an electron loose and that balance breaks. Now you've got a charged atom called an ion, and that tiny imbalance is exactly what fires the nerves in your brain, powers the battery in your phone, and makes the salt on your food, well, salt. And that's the entire cast. 3 particles. 1 positive, 1 neutral, 1 negative. Arrange them in different numbers and you don't just get one thing. You get every element on the periodic table, every molecule, every material, and you. The whole universe, written with a 3-letter alphabet. Not bad for just 3 little pieces.